Okay, so this is our final lesson for the school year. Yay! It's going to be somewhat jam-packed. I'm sorry. Just because we had such little time. I know I've been kind of piling a lot of information on you guys, but this is literally it for the year. Okay, so we're going to first start with solving radical equations. So make sure you have those notes open for this lesson first. So before we talk about solving radical equations, we need to talk about these things called extraneous solutions. Okay, and these are going to come up a lot junior year. I just kind of want to introduce you to them. An extraneous solution is a solution that doesn't actually work when you plug it into your equation. It actually gives you a false equation when you plug it in, which is a little frustrating. I solved for the variable, but now I have to check to make sure it actually works. But sometimes there's cases where that number doesn't actually work in our equation. Okay, a quick trick to know if your answers are going to work or not is when you get your square root all by itself and your square root equals a negative number, it's not going to work. Okay, and we also don't have a solution if that happens. Because the square root cannot equal a negative number, right? Because when you take the square root of a number, you're finding what number times itself gives you the number on the inside. So I listed out the steps for you guys. First, you need to isolate one radical to a side of an equation. So I have a square root by itself, nothing on the outside of it on one side of the equation. And then to get rid of the radical, we're going to square both sides, right? It kind of undoes the square root. And then we're going to have to solve, and sometimes that's going to be by factoring. Okay, and then check your answer in the original equation to make sure it's not an extraneous solution. Okay, so in number 1, my radical is all by itself. There's nothing on the outside of it, right? All it is that radical. And so when that happens, all you do is square both sides. Okay, when you square a square root, the square root goes away and you're left with what's inside. So that just becomes x. And then you're squaring the 10, so that becomes 100. And then that's your final answer. Okay, and what I mean by check is to just plug in x into your square root. So instead of x, I'm going to put 100. Does the square root of 100 equal 10? Yes. Okay, so x equals 100 is my answer. Now, you don't have to do that every time. I'm going to teach you a quick trick so you don't have to actually check and plug it in every single time. And I'll show you how to do that in number 2. So in number 2, again, my radical is isolated. There's nothing on the outside of it. It's all by itself on one side of the equation. So I'm going to go ahead and square both sides. Make sure you square both sides, okay? And so the square root goes away and I'm just left with m plus 7 without the square root, and then equals 16. And now I'm going to solve for m. So I have to get m by itself. So I'm going to subtract by 7 on both sides. And then m equals 9. Now to check, just ask yourself, is my radical all by itself, and is it equal to a positive number? Okay, if I don't have an m on this side and it equals a positive number, then I'm okay. I'm gonna, no matter what, get an answer when m equals 9. Okay, and I'll show you again what that looks like in these other examples. So in number 3, see how I have this -1? It's not underneath this right here. So that means that I need to get rid of this before I could square things. Okay, you have to get rid of the stuff on the outside of the square root before you square both sides. So to get rid of it, it's just like solving any equation. I'm going to do the opposite and add 1 to both sides. And so I have the square root of 2n plus 16 equals 6. Now I don't care about all that stuff inside of the square root. That's fine. All I care about is getting rid of the stuff outside of the square root. Okay, and once I do that, I'm going to square both sides. So I get 2n plus 16. That's now outside of the square root because I squared it. And 6 squared is 36. I'm going to subtract both sides by 16 because now I'm trying to solve for n. So 2n equals 20. Okay, then I'm going to divide by 2 So n equals 10. So to check to make sure that this answer works, go to the step where you got your square root by itself. There's no variable on this side of the equation, so no matter what, my radical is going to equal a positive number, which means that my answer is going to work no matter what. Okay, so I don't even have to plug in 10 for n and figure it all out. Okay, I already know nothing's going to change. This is always going to stay positive because there's no variable on this side to plug into, so my answer is okay. Now in number 4, it's a little bit different because both sides equal square root. Just as so long as one of the sides is isolated, there's nothing on the outside of that square root, then you're okay. That's not, I mean, it's kind of always going to be looking like this for you guys. Once you get to junior year, it might look a little bit different with some stuff outside of the radical, but it's okay that both sides equal a square root. Okay, just as so long as one side is all by itself, and I'm going to go ahead and do the same process. I'm just going to go ahead and square both sides. Now when I do that, nothing on the inside changes. Do not square the 3r, do not square the 24. All that's happening is the square root is going away. And the same thing on the right side. You're not squaring the 4, you're not squaring the r, the square root just goes away and you're left with the inside, which is negative 4 minus r. Okay, and then you're simply just going to solve for r. You need to get r by itself. So I'm going to move the variable over by adding r. So I get 4r plus 24 equals negative 4. Then I'm going to subtract both sides by 24. So 4r equals negative 28. Divide by 4, so r equals negative 7. Okay, and in this case, my answer is going to work no matter what. If you want, again, you could check. I will check over here. Because my square root is never going to equal a negative number. That's all I'm looking for. Does my answer make my square root equal a negative number? If my answer doesn't make my square root equal a negative number, then I'm okay. So I'm going to plug in r. Again, you don't have to do this. You can even do it mentally if you want. I know some of you are good at kind of doing this in your head, so I'm totally okay with that. Minus negative 7. Okay, so let's just make sure both sides equal the same thing. Negative 21 plus 24. Square root of 3 equals negative 4 plus 7. Sorry, I should have did that up here. And then when we combine those, we get the square root of 3. Both sides equal the same thing. So my final answer is r equals negative 7. So my answer could be a negative number. Just when you plug it in, your square root cannot equal a negative. Okay, so you can have negative answers. Just when you check your answer, your square root can't equal a negative number. Okay, finally, number 5. I have a square root. It's all by itself. There's nothing on the outside of it. Okay, if there's nothing around this, then I'm good. And I'm going to go ahead and square both sides. So this becomes b squared equals, again, don't square the inside. The square root just goes away. So I get 72 minus b. Because I have a variable squared, that means you have to solve by factoring. Okay, again, when we solve by factoring, you need to make sure your equation is set equal to 0. So that means I have to move everything over to one side. So I'm going to bring over the b and the 72 and make sure you're putting it in the correct order. Biggest exponent to smallest. So b squared comes first. I can't combine these two because they're not like terms. So it's b squared plus b minus 72 equals 0. Now all you're going to do is look at this side and factor it, right? Reverse FOIL. So it goes b and b, and then it's got to multiply to be negative 72, but add to be positive 1. That's positive 9 and negative 8. Okay, remember then you set both of the parentheses equal to 0 and solve. So b equals negative 9 and b equals 8. Now we need to check these answers. So go back to where your square root is isolated. So this step right here. And then again, I'm just going to teach you the trick so you don't have to go ahead and calculate this all out. If I plug in for b right here for negative 9, I'm having my square root equal a negative number, which cannot happen. Okay, that's what I mean when your isolated square root equals a negative number. When you plug in your answer, that can't happen. So this cannot be an answer. Okay, if I plug in for positive 8, well then my square root, no matter what equals is over here, this is fine. My square root's going to equal positive, then it's all going to calculate out and it's all going to work. So b equals 8 is my only solution. Now, if it was the case that both of those would make your square root equal a negative number, well then you would just have no solution, right? None of the answers work, I have no solution. So that's kind of a quick trick. If you don't like that shortcut, you could always plug in everywhere for b. So 8 equals 64, the square root of 64 equals 8. So like I said, it's going to work no matter what. Okay. You could go ahead and do the u-tries, but if you are, I recommend just doing 1 through 3 and then come back. And I'm going to explain how to do 4 because that one's a little bit different. You're going to see that on your homework. Okay, so number 1, it's already isolated, so I'm going to square both sides. So the square root goes away, and I'm just left with the inside, so m over 2 equals 9. And remember, to get m by itself, think to yourself, what's being done to m? Well, it's being divided by 2. Well, what's the opposite of dividing by 2? That's multiplying by 2. So m equals 18. My isolated radical equals a positive number. There's no variable over here that I could plug in for m. So no matter what, it's going to equal positive, so 18 works. Okay, number 2. So I have something, ding, 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 outside of my radical that I need to get rid of. It is not being subtracted to my radical. Okay, it's not being, subtracted from my radical. Think of what's the operation in between these two. That's actually multiplication. Well, how do you get rid of something that's being multiplied? You divide. So I'm going to divide both sides by -4. And so I get positive 3 equals the square root of 29 minus 2k. Now my square root's by itself, so you're going to square both sides. So 9 equals 29 minus 2k. Now let's get k by itself. So -20 equals -2k. Divide by -2. So 10 equals k. Now going back to this step where my radical is isolated, can I plug anything in for k over here? Nope, my radical equals a positive. So no matter what, this answer is going to work. Okay, number 3, already isolated, so I'm going to go ahead and square both sides. So the square root over here goes away, and you're just left with what's inside, and this becomes an a squared. So since I have a variable being squared, I have to solve by factoring. Okay, when you are setting this up and setting your equation equal to 0, don't subtract the a squared. Don't do that, because when I'm factoring, the variable squared cannot be negative. So instead, I'm going to move everything over to the right side so that this term is going to stay positive. So I get 0 equals a squared plus 2a plus 1. And now I'm going to factor. So a and a, it's got to multiply to be 1 and add to be 2, so that's 1 and 1. Set equal to 0. So a equals -1, a equals -1. So since these are both the same number, I just have to check it once. Well, if I plug in for a right here, I don't even have to calculate this out. You don't even have to plug in for the a that I just did, but equals -1. Whoop. That's making my radical equal to a negative number. Not okay. And since both of them are equal to -1, I don't have a solution. So I'm just going to say no solution. Both of those don't work. Okay, finally, number 4. So this one's slightly different. So if you just skipped over 1 through 3, okay, please make sure you take notes on at least number 4 because it's different from the other examples. I have this outside of my square root, I need to get rid of it before I square both sides. So I'm going to add x to both sides. And now I'm going to have the square root of x plus 8 equals x minus 4. Okay, now that my square root is by itself, I'm going to square both sides. When I square the left side, that just becomes x plus 8 with the square root gone. But over here, this is actually saying x minus 4 times x minus 4. So what do you think you have to do when you have those two parentheses? Right, we have to FOIL. Okay, so when I FOIL this out, this becomes x squared minus 4x minus 4x plus 16. Let's combine our like terms. So x squared minus 8x plus 16. Okay, I have a variable squared. That means I'm going to be solving by factoring. So I have to bring everything over and set it equal to 0. When you're bringing everything over, make sure you're combining your like terms on the other side. So I have 0 equals x squared minus 9x plus 8. Okay, now I'm going to factor that side of the equation. So I know I get x and x in the front. It's got to multiply to be positive 8, but add to be negative 9. That's negative 8 and negative 1. So x minus 8 equals 0. X minus 1 equals 0. So I get x equals 8. X equals 1. Now let's check. Okay, all you have to do, super simple, I'm going to teach you the shortcut, is plug in for x on the right side of the equation, okay? Because I need to determine, do any of these numbers, when I plug in for x, make the radical equal to a negative number? So plug it in. I have x is equal to 8, so 8 minus 4, that gives me positive 4. Okay, so that's fine. Now let's try positive 1. So 1 minus 4, that equals negative 3. That cannot happen. Okay, I have my square root. It's going to end up equaling a negative 3. We don't like that. So x equals 1 can't actually be a solution. So my only answer in this case is x is equal to 8. Okay, that's it for solving radical equations. It's a pretty quick process. And now we're going to move on to solving quadratics. So I want you to open your other set of notes and then start following along with me here. So solving quadratics. So quadratics are equations that have something that's being squared. Okay, and there's 4 ways to solve a quadratic equation when a variable is being squared. So the first way is factoring, which we literally just did in the previous problems I just went through, right? I have to get it set equal to 0. I factor, I set the parentheses equal to 0, and I solve. Okay, so we've done this plenty of times throughout the year. The second is taking the square root, probably the easiest method, but it doesn't work in every single case. The third is the quadratic formula, and the fourth is completing the square. So we're not actually going to learn the fourth one because we're going to learn that junior year. And since we already did some examples with factoring, all we're going to talk about now is taking the square root and using the quadratic formula. Okay, so you take the square root. When you're solving quadratics and you want to use taking the square root, the time that is appropriate to use this method is when all you have is a variable squared and not another variable present. So let's say this was like p squared plus p equals 100. Well, since we have this p, we wouldn't use taking the square root. Okay, that wouldn't be the method we would use. I would need just p squared and not another p. Okay, so when you are solving equations by taking the square root, just make sure that your variable squared is by itself. Don't set it equal to 0. Just make sure your variable squared is by itself. And then we're going to do the opposite of solving radical equations. So instead of squaring both sides, to get rid of the square, I'm going to take the square root. Okay, when we take the square root of p squared, that's just going to give us p, and it's going to give me 2 answers. Can you think of what numbers, when multiplied together by the same thing, would give you 100? Well, that would be 10 and negative 10, right? 10 times 10 gives you 100, and negative 10 times negative 10 gets you 100. And another common way you'll see your answers written is plus minus 10. So that means that your answer is positive 10 and negative 10. This is probably the most common way you'll see your answers written as you go through other math courses. So I'm going to continue to write it as a plus minus. Okay, if you want to write it as two separate answers, I'm totally cool with that. So in number 2, my variable is alone, that's being squared. So what I'm going to do is undo that square by taking the square root of both sides. So I get b equals plus minus 8, right? It's positive 8 and negative 8. So if you wanted to write your answer as two separate things, it would be 8 and negative 8. Okay, but I'm going to keep my answer like this. Okay, number 3. So the b squared is not by itself. So what I'm going to do is get rid of this negative 6 first. So I get b squared is equal to, let me do this in my head. So this would be 448. Okay, and then now I'm going to take the square root of both sides. So I get b equals plus and minus, so the positive and the negative, of the square root of 48. Now that's not a perfect square, so I'm not going to get a whole number, but you have to make sure you simplify your answers, right? So I need to find the biggest perfect square that goes into 48, so this is fully simplified. So we have 16 and 3. So 16 is my perfect square, so that's going to come out. So b equals plus minus, well, the square root of 16 is 4. And we have 3 left in the square root. So it's positive 4 root 3 and negative 4 root 3. Okay, with number 4, I need to get b squared by itself. So I'm going to subtract 9 from both sides. So b squared equals 58. So I'm going to take the square root of both sides. So b equals plus or minus, so positive, negative, of the square root of 58. And let me just check really quick, is there a perfect square that goes into 58? 4, nope, not 9. Okay, so there is no perfect square that goes into 58, so I can't simplify that further. So my answer is literally just positive square root of 58 and negative square root of 58. Okay, number 5. Again, we want to get x squared by itself, so I'm going to add 9 to both sides. So x squared equals 50. Now I'm ready to take the square root of both sides. So x equals plus or minus the square root of 50. But we got to simplify. I know 25 is a perfect square that goes into 50. So I'm going to take the square root of 25, which is 5, and all I have left in there is 2. So positive 5 root 2 and negative 5 root 2 are my two solutions. Okay, number 6. I'm going to add 6 to both sides. Add 6 before you divide. Okay, make sure you add and subtract before you divide. So I get 49k squared equals 4. And then to get k squared by itself, I need to then divide both sides by 49. And then I'm going to take the square root of both sides. So remember, when you take the square root of a fraction, you just take the square root of the top, which is 2, the square root of the bottom, which is 7, and I know it's the positive and negative of that answer. So again, you're giving me two answers, the positive and the negative. Okay, and that's literally it for taking the square root. Super, super simple. But again, you can only use it when you only have a variable squared and not another variable with it. Now, the quadratic formula is super important because you could use the quadratic formula to solve any type of quadratic equation. Even though you could solve by factoring and you could solve by taking the square root, you could also use the quadratic formula no matter what. And it's super important to know the quadratic formula because sometimes you'll have things that you cannot factor. There's just sometimes you have a polynomial and the numbers don't work out and you cannot factor it, and you have to use the quadratic formula. So you can use when you can't factor, okay? And you'll end up using this a lot junior year. Okay, so the quadratic formula, to solve for x, we're going to use the opposite of b, so a negative just means opposite, plus or minus, so my two answers are coming from the plus or minus, the square root of b squared minus 4ac all over 2a. Okay, so these a's, b's, and c's are coming from when you have a quadratic equation that looks like this. So you have your equation set equal to 0. You get your a from in front of your x squared. You get your b from in front of your x, and your c is your number that's by itself, that's not by a variable. So whatever numbers are there, you're going to plug into that formula. And the quadratic formula has a song that helps you remember it. Unfortunately, I have to sing it on here, and it's going to be on YouTube forever and ever, but I honestly still sing the song till this day when I'm filling out the quadratic formula. So hopefully you guys remember it. You could use it when you go on through your other math classes. You'll be singing this song in your head too when you're doing the quadratic formula. So it goes to the tune of Pop Goes the Weasel. Okay, so it's the opposite of b plus or minus square root b squared minus 4ac all over 2a. Got it? Okay, I'm going to do it one more time. The opposite of b plus or minus square root b squared minus 4ac all over 2a. Okay, sorry for making you guys' ears bleed, but I highly recommend you guys sing this in your head or you sing it out loud until you finally get the formula, because it's going to make your life so much easier when you go through other math classes knowing the quadratic formula. Okay, so when we're using the quadratic formula, it's kind of like setting it up as if you're going to solve by factoring, okay? So you need to make sure everything is set equal to 0, which in number 7 it is, and I need to identify my a, b, and c. Okay, here's my a, here's my b, here's my c. So a equals 3, b equals -9, make sure you're taking the sign with it, and c equals -54. Okay, so now what you're going to do is plug it in to the formula. So x equals the opposite of b. Well, b, we said, is -9. Well, the opposite of -9 is +9, plus or minus the square root of b squared. So when you're squaring b, make sure you're putting parentheses around it, because if you type it in your calculator without the parentheses, it's going to give you the wrong answer. So make sure you have the parentheses. Those are super important, because if you don't have the parentheses, it's like squaring -9, and it's just going to give you -81, but I need it to be positive. Okay, this number right here is always positive when you multiply it out. Okay, when you square that, it should always be a positive number. If it's not a positive number, you're not typing it into your calculator correctly. Okay, so I get b squared minus 4. The 4 is always going to be there, times a, which is 3, and c, which is -54. Okay, all over 2 times whatever a is, and in this case, a is 3. So once you plug it in, literally all you're doing is calculating this out. Okay, so I'm going to start with the inside of my square root first. So -9 times -9, that's +81. And then you're multiplying -4 times 3 times -54. Now, a lot of people try to distribute the -4. Please do not do that. You're literally just multiplying those three numbers together, and it doesn't matter what order you do it in. So I'm going to do -4 times 3 times -54. And I get positive 648 all over 6. Okay, so I'm going to keep combining what's inside of the square root. So I'm going to do 648 plus 81, which is 729. over 6. Now, in your calculator, make sure, I want to make sure that my answer is as fully combined and simplified as it can be. So I'm going to see, is 729 a perfect square? So I'm going to take the square root of 729, and I get 27. So it is a perfect square. So 9 plus or minus the square root of 729 is now 27 all over 6. Now, 9 and 27 could be added and subtracted together, right? Those are like terms. So to get your two answers, I have to split this up into an addition and subtraction. So I have to do 9 plus 27 over 6. And then I have to do 9 minus 27 over 6. So if you can combine these two things, you have to set it up into two separate answers and combine 1 plus, 1 minus. So when I combine 9 plus 27, I get 36 over 6. 36 divided by 6, that's just 6. So one of my answers is positive 6. And then I'm going to do 9 minus 27, that's negative 18 over 6. So negative 18 divided by 6, that's negative 3. So x also equals negative 3. And there's no checking involved. Those are literally my two answers, and then I'm done. Okay. So in number 8, it's already set up nicely for me. It's already set equal to 0. So I'm going to identify my A, B, and C. So A equals 5, B equals 7, and C equals negative 34. Okay, and I'm going to plug it into the quadratic formula. So now instead of x equals, I'm going to use r equals because that's my variable. So r equals the opposite of b. So the opposite of positive 7, that's negative 7, plus or minus the square root of b squared, so 7 squared, minus 4 times a times c, all over 2 times a. Okay, let's use our calculators to calculate this out. So negative 7 plus or minus the square root. So 7 squared, that's 49. And then in my calculator, I'm going to type negative 4 times 5 times 34. I get positive 680 all over 2 times 5, which is 10. So now I'm going to keep combining inside of the square root. So negative 7 plus or minus 680 plus 49. I get 729 again, all over 10. So from our last example, I know that 729 is a perfect square. So I could take the square root of 729. I'm going to get plus or minus 27 over 10. Okay, because I can combine negative 7 and 27, I'm going to split this up into my two answers. So negative 7 plus 27 over 10, and then I'm going to do negative 7 minus 27 over 10. Okay, so I get 20 over 10, so r is equal to 2. And then I get negative 34 over 10, and I'm just going to simplify that. So I get 17 over 5. We're going to make that negative, and those are your final two answers. Okay, last two examples. So in number 9, my answer is, or my problem's not set equal to 0, so I have to make sure I do that before I identify my A, B, and C. Ooh, I don't know why that came out like that. So I get 12v squared minus 12v minus 3 equals 0. So let's identify our A, that's 12, our B, that's negative 12, and our C, that's negative 3. Okay, and we're going to plug it in. So v equals the opposite of b, so that becomes positive 12, plus or minus the square root, b squared, make sure you use your parentheses, minus 4 times a times c, all over 2 times a. Okay, now we're simply just calculating this out in our calculator. So the square root of 144, make sure you're getting positive 144. And then you're going to do negative 4 times 12 times negative 3, sorry. And so that gives me positive 144 over 2 times 12, which is 24. Okay. So combine the inside, so 144 plus 144, that's 288 over 24. Now, in your calculator, take the square root of 288 and see if you get a whole number. If you don't, 288 is not a perfect square. Okay, so what you need to do now is you need to fully simplify your answer. Now, we know how to simplify a radical, right? I need to split up 288 into a perfect square times something else, right? So what is a perfect square that goes into 288? Well, that's 144 times 2. Okay, so I'm going to take out that 144. The square root of 144 is 12, and you're left with the square root of 2. So all I did was simplify the radical, square root of 288, all over 24. So when you're doing problems like this and you have to simplify the radical like that, check all 3 of your outside numbers and ask yourself, can you divide all 3 of those numbers by something? Now, if there isn't, then your answer is done. Okay, but if there's something that goes into all 3 of those numbers, and it has to be all 3, it can't just be 2. Okay, it has to be all 3 of those numbers. I see something that goes into all 3 of those, and that is 12. So what you're going to do to fully simplify this is divide all of those front numbers by 12. Okay, so I'm going to get 1 plus or minus 1 root 2. If you don't like the 1 there, you could just leave it as root 2 all over 2. And since you cannot combine the 1 and the square root of 2 because they're not like terms, you don't have to separate it into your 2 answers. What variable am I using? This is representing my 2 answers already. It's saying 1 plus root 2 over 2, and then it's saying 1 minus square root of 2 all over 2. Okay, so you don't need to separate it into 2 answers. You can literally leave your answer like this when you have the square root left in the numerator. Okay, and then last one, I need to make sure it's set equal to 0, so I'm going to subtract 5r from both sides. So I get 9r squared minus 5r minus 7 equals 0. So my a is 9, my b is negative 5, and my c is negative 7. So r equals the opposite of b, so it's going to be positive 5, plus or minus the square root. So I get negative 5 squared minus 4 times a times c all over 2 times a. Now let's calculate this out. So negative 5 squared, make sure in your calculator you're getting positive 25. And then I'm going to type negative 4 times 9 times 7. I'm going to get positive 252 all over 2 times 9, which is 18. So add 25 and 52, I get 277 all over 18. Now you have to ask yourself, is there a perfect square that goes into 277? In this case, there is not. So your job is super easy. This is your final answer. Okay, so literally all you had to do was multiply and add some numbers together, and then you're done. Okay, really quickly, I'm not going to do this whole thing, but just as an extra example, because I know this will pop up on your homework, let's say I had something like this. Let me just use x. X squared minus 10 equals 0. If you're missing a term, this is my a, so a is equal to 1. If I don't have my b, then that's just equal to 0, and then my c would equal negative 10. Okay, so if you're missing a term, that number is just equal to 0, if that makes sense. Okay, and if you have an invisible number in front, remember that's 1. And then that's it. Okay, that is it for Algebra 1. I'm sorry that the year ended this way, but you guys survived, and I hope you guys have a great summer.